Hello everyone, myself Bhavani, Assistant Professor of IT Department in SMIT. We are going to see about the database management system. We are going to continue with the second unit. Course outcome will be design database using ER model and normalize the data. Nothing but designing the database using entity relationship model. And then going to see about the normalize the database. How we are going to handle the database with the advanced models and topics. Unit 2 will be database design. We are going to design the database likely how using entity relationship model. See, we are continuing with the functional dependency. It's nothing but functional dependency is a database management system. Like it's a constant that describes how the relationship between attributes. Nothing but relationship between attributes means like it is a columns in a table where one set of attributes uniquely determines the value of another set of attributes. See, like two tables will be there. We are going to see about the one set of attributes uniquely, and then it will relate with the another set of attributes in the another table. Dependency is denoted as C, X, Y cap, X right arrow cap, Y. Nothing but X, Y. Pronounced as S, X functionally determines Y, or Y is functionally dependent on X. Here X and Y, X is determinate and Y is dependent. See X, the attribute or set of attributes on the left side of the arrow. Dependent attribute or set of attributes on the right side. This means that for any two rows in the table with the same values for X, they must also have the same values for Y also. Then we are moving on to types of functional dependency. Types of functional dependency classified as trivial, then non-trivial, partial, full, and then transitive. Now, trivial. Dependent attribute or a subset of determinant attributes. Okay. It is a subset. Example, employee ID and then name. Next, moving on to non-trivial. Dependent attribute or not a subset of determinant attributes. Example, employee ID. Okay. And name. See, moving on to partial. A non-key attribute is determined by only part of composite candidate key. And then full and non-key attribute is dependent on the entire composite key. And then transitive. And indirect dependency exists through a third attribute. If A to B cap, A right arrow cap B, okay? And then B to C cap, right arrow cap C. Then A to C, right arrow cap C, right? A to C cap. This has been identified for functional dependencies. Now we are going to see why functional dependency is important. Actually, functional dependency is essential for database design and normalization, but they are used to reduce the redundancy, maintain data integrity, facilitate normalization, enhance query performance. See, what is reducing redundancy means nothing but by structuring tables based on functional dependency, data repetition is minimized. Maintain data integrity. Actually, functional dependency enforce constant, ensuring data is accurate and consistent. Facilitate normalization. Functional dependency forms the basis for achieving various normal forms which organize data and mitigate anomalies. Enhance query performance. Normalized database generally allows for more efficient queries. Moving on to non-loss decomposition. Actually, lossless decomposition split the table into smaller tables like having relation 1 table, relation 2 table, such that the natural join exactly reconstruct the original table, okay, without creating extra superior tuples. It is essential for maintaining data integrity during database normalization. Actually, there are some conditions for these lossless decomposition. Nothing but after decomposition, union of attributes of x1 and x2 must be equal to the attribute of the original relation x. X1 and x2 must have at least one common attribute, okay? Like interjection should not be null. Common attribute must be a super key in at least one of the decomposed relation. Common attribute should have unique values to ensure a lossless join. See, this is the example. Actually, A, B, C were the value. This is the original table. Like it has been spreaded into A cap C and then B cap C. Nothing but everything common table will be C. So with the relation to C, original table can be formed. This is the example given. Actually, see, to check lossless decomposition means ensure that there are only three major things. Suppose any relation R with ABCD is decomposed into relation R1, ABC, and R2, C and E. Then check for union of attribute set. R1 and R2 should be equal to the attribute set of R. Relation 1, union relation 2 gives the original table of R. Intersection of attribute set. Relation 1 and relation 2 should not be empty set. Empty set will not equal to null value. Attribute closure of intersection of attribute set of R1 and R2 is either superset of R1 or R2 gives the section table twice. Not all decomposition into normal forms 1, 2 or 3 or Boise code are guaranteed to be lossless. These are the checked as for lossless decomposition with these not rated. C. Moving on to normal form. There are 5 normal forms, okay? Which stricter than the previous one, making higher normal form employs the lower one or satisfying. Actually, what is the benefit of using normal form? Like while we using normal form, it reduces the duplicate data and wasted storage. Prevent insert, update, and delete anomalies at all. Improve data consistency and then integrity. Make the schema easier to maintain and then have. See, this is the image representation of 5 normal form. First layer will be first normal form, second normal form, third, and then Boise-Code normal form, fourth normal form, and then fifth normal. First normal form, actually table is in first normal form. If it satisfies the following condition will be column should contain the atomic values like indivisible values. Each row should be unique. So no duplicate rows are allowed. Each column has a unique name. Okay. Order in which data is stored does not matter for first normal. Example, if a table has a column phone numbers that store multiple phone numbers in a single set, it violates one normal form. To bring it into first normal form, you need to separate phone numbers into individual rows. Then it will shift into first normal form. Moving on to second normal form, eliminating partial dependency. Second normal form satisfies the condition of first normal form and additionally, since no partial dependency exists, meaning every non-prime attributes, like non-key attributes, must depend on the entire primary key, not just a part of it. Okay. Example, for second normal form, you are using a composite key for student ID and course ID. If the student name depend only on student ID and not on entire key, it violates second normal. To normalize the second normal form, move the student's name into a separate table where it depend only on student ID. Then this condition will satisfy the second normal form. Moving on to third normal form, actually little bit most important. If third normal form satisfies only, we can move this into Boise code normal form. See. Third one is eliminating transitive dependency. If this relation need to satisfy, it need to satisfy before the second normal form. And then they have additional content. There are no transitive dependency. Simple term, we can say it as non-prime attribute should not depend on other prime attributes. Example, if a table with student ID, course ID, instructor, if instructor depends on course ID and course ID depends on student ID. Instructor indirectly depend on student ID, which violates the third normal form. To resolve this, place instructor in a separate table linked with the course ID. See what are the applications of normal form and DBMS method. Ensures that data consistency, reduce the data dependency, improves query performance, enhance data integrity, easier database maintenance. These are the most important applications of third normal form. Thank you.